Howdy everybody, and welcome back to the Chip and Dale tutorial. And so last time we left off with a little bit of a mystery on my end, but I figured out what was wrong with it, so let's get cracking today. We are going to be working on getting our player into the world today. So last time, like I said, we left off with a little bit of mystery. I was wondering why things weren't exactly matching up properly. Then I remembered, oh yeah, it's because my camera is still just a blank object. I haven't filled in any of the code yet because, well, we don't have a player character for it to follow around yet. So we just finished up with the cutscene. So that means that we do now have, well, a pathway to the main game. So that means we can get started with our rooms. So let's see, we are going from room init to room title to room cutscene, and these ones don't need to be right there. I should actually put a subfolder for them, but so from room cutscene we are going to room 01. So if you have downloaded the project file, you should have this room already tiled and set up. If you have not downloaded the project file, well, then you're out of luck. Let's see if I can show you. If we come over to the finished project here, this is what it looks like when it's finally finished. Stuff like this doesn't need to be in there. Anyways, so we have a couple of layers. So we have like a particle event. Well, these are all instance layers here. So we have particles, and I use this for, well, particle effects. And instances, which is just the general throw-in term. Enemies, I put it back here behind instances because the player object is going to be in instances. So by putting the enemies underneath the instances, whenever you get hit by an enemy, you are drawn on top, so you don't end up being drawn behind the enemy, so you can't see where you are and lose focus on where you're at and die because you didn't see where you're going. And the same thing applies for throwables and pickables. So throwables would be stuff like the crates, and pickups would be the little flower tokens. I have no idea what they're supposed to be. I mean, as related to Chip and Dale, I think they were just completely made up whole cloth for the game specifically. Then we also have a collisions tile layer, because we are going to be using tile-based movement. So this is, see if we can move in here. We have three different types of solids. We have the solid tile. We have a platform tile. So this would be tile 0. This is tile 1. And we have a spiky tile, which would be tile 2. Oh, wait. That would be 0, 1, 2, 3. Yeah. That would be the blank space. And real quick, so you can see the platform tiles right along there, and along there, and along there, and so on and so forth. Spikies are right here. And there's also a solid layer right there. So you can't jump up into them, but you can jump into the side or on top of it. Anyways, then of course we have the tile layer and a background, which is just a light blue, which is what was in the game, I believe. So, alright, let's get on with this here. So, we have a room, and we are going to want to fill it with some stuff. So, let me take a look over my stuff here. We have transitions, music player, etc. Making sure we actually have everything. So let's go down over to the player object, and let's get started on this guy here. Let me pull up all the code. Alright, good. Let me zoom you in. And here. Create object. Object underscore player underscore 1. Alright, let's give him a sprite here real quick. Chip. And we'll probably just give him chip idle. And let's do a create event. We're going to have to create a whole lot of variables for this guy. His code is fairly complicated overall. To get us started, we have player states. Enum player underscore states. Move, 0 duck, 1 carry move, throw, jump, hiding, hurt, stunned, death, carry jump, lift, duck underscore covered, and balloon. There's so many of them, I decided I'd just manually number them so I could remember what number every single one of these states are. I never did actually program balloon state, but if you want to, so I add the basics so that you can set up multiplayer, but I don't really go into adding multiplayer too much. But if you want to add in multiplayer, then you would just have to add a balloon state really to the player object. And of course, duplicate all the code over to a second player. And theoretically, the second player would work exactly the same as the player 1, except you would change all the inputs to be referencing the player 2 controls instead of player 1 controls. Alright, so yeah, we have a bunch of states here. And we're just going to close that up. And next up, we are going to add in some animation variables. Alright, here we go. So image speed equals 0, because we don't want our character to be animating. He's going to start off in the idle state, or the move state, I guess. No, I guess I can make him in the idle. Actually, the move state has idle in it. Alright, so we'll just ignore that. Animation speed 0.5, so that's how fast his frame is animating compared to. And direction facing dir4.right. Again, dir4 is in our macros. Enum dir4. We also have dir8, but we're not using dir8 in here. Our state, player states.move. iframes equals false for whenever we want to be invincible. Iframe time is how long you're going to be invincible. And the timer is the timer that's set up to count down how long you're invincible. I set up a lot of timers manually rather than using the built-in timers. That way, when you pause the game, you can pause the timers as well. Then we have the manual sprite change. This is a new variable I created for this course. Yeah, so this is a new variable I created for this course, which allows us to manually change the sprite whenever we need to for certain actions. Animation underscore timer. Again, we use this is used in some of the states so that we can say, okay, after 5 frames, go to the next frame in your animation, because the animation, well, I could have done it by just setting up the sprite to have multiple frames. Whoops. But I just set up an animation timer instead, so that I would say after 5 frames, swap to the next image, and then after another 5 frames, swap to the next image, because not only do you have to well, instead of having a custom sprite animations for every single action. Pickup underscore will be used for picking up items. Pickup underscore name, again, used for picking up items. And hiding for hiding inside items. Now we'll come over here to the global.character equal to 1. So if we are character 1, then our character name is Chip, and our image blend would be C_red. And you can see, because I didn't import Dale's sprites, or whoops, your name should be Dale then. Well, I left it at Chip because yeah, this reason below. Else character name would be Chip, and we use this in our sprite table for being able to actually see our character, for being able to dynamically change our character's sprite based on what character choice you chose for the player 1. Alright, so moving on, we're going to go into our input. We have X_input, Y_input, jump input, pickup input, select input, and start input. So that would be like A, B, well, that'd be left and right, up and down on the D-pad, A and B, and select and start on the NES controller. So yeah, that's all the inputs. And we set them to 0 by default. Next up, we have movement variables. Let's see here. We are going to be using Y fractions and X fractions to allow us to move in fractional percents, fractions per frame. We are going to have an acceleration of 1.75, and all these values are based on my best guess from playing Chip and Dale incessantly and using an emulator to go over the game frame by frame to see exactly how many pixels they move and all that fun stuff. And I think I got all the emulations correct, but there's some slight differences, but probably. So our acceleration 1.75, friction 1.75, gravity 0.36, jump speed -8, because remember you're jumping upwards and upwards is subtracting from Y value. Max speed 1.75, and as you can see the acceleration is 1.75 and the max speed is 1.75 because, well, you instantly reach max speed when you start moving. And the fall speed would be 8 as well, so you're kind of going as fast up as you are down. And our X speed and Y speed variables, which we will need for being able to move around. And last but not least, our collision variables. Tile map equals layer underscore tile map underscore get underscore ID collisions. We're getting this layer there. And on ground equals false. All right, last but not least, the big sprite lookup table. And you know what a sprite lookup table is, I believe. So we're using asset underscore get underscore index to create our sprites rather than actually just setting it equal to a sprite name directly. So instead of saying sprite underscore chip underscore carry jump or whatever, instead of doing that, we use asset underscore get underscore index and create a name using the character name that we set up over here. Alright, so there's going to be a lot of code in here, so I'm just going to scroll through this and you can pause and copy it as you want. So I have it all separated into states, so we have move state, duck state, carry state, throw state, jump state. Well, I guess I should explain, just for those who aren't familiar with it. Sprite tables allow us to quickly look up what sprite your character should have when they're looking left, right, up, or down, depending on what state the character is in. So if they are jumping, should I have this sprite or what? Or if I am diving or whatever. So we use a array here, a 2D array, or oh wait, is this 2D or is it 1D? I think it's 2D. So we have player underscore states dot move and dir4 dot right. So at position, so move is the 0 state. So at position 0 and dir4 dot right would be 0. So 0, 0, then you would get this value here. You would get this. You would get the sprite that's name corresponds to the name that we create in this string. All right. So let's see. So you can pause it as you need to look at the various state code and copy it to your game. So it's fairly simple, you know. Just duck covered, so sprite underscore character hurt. It's all the same sprite for each one of these, each 4 of these, because I'm not using different sprites for left or right. But so it's fairly simple. Alright, I think that's everything there then. So we should be able to create our character now. So let's go back over into the room 0. Make sure we're on the instances layer. And let's put our player object into the world. And let's give this a look. We at least made it to the world, but it doesn't seem our camera is following our character yet, because like I said, it's just an empty shell. So next time I believe we will set up the camera so it'll actually follow our character around, and I'll show you the various, it's really complicated what I had to do to set it up so that it would emulate what happens in the NES. It'd be so much nicer if I could just use the cameras that people use nowadays, which kind of stretch and whatnot if there are multiple people on the screen, but not in this case. So anyways, thank you everybody for watching, and remember, if you have any questions, don't hesitate to ask or leave a question or comment, and I would love to hear your feedback. So thank you everybody again, and good luck with your programming.